In this video, we want to find the integral from 0 to 1 of x cubed over the square root of x squared plus 1 dx. We're going to solve this using two different methods. The first method, we're going to use integration by parts. So I'm going to ignore the limits first, and I'm going to find the indefinite integral. So we start off by breaking up x cubed as x squared times x. And we're going to let u equal x squared, and dv will just be x over the square root of x squared plus 1 dx. Now at this point we take the derivative of u, which is just 2x, and then the antiderivative of x over the square root of x squared plus 1 is just the square root of x squared plus 1. And here's why that is. In order to solve this integral, we have to use u substitution. We'll let u equal the square, or just x squared plus 1. So du is 2x dx. So that means x dx has to be du over 2 when you divide both sides by 2. We'll factor out the 1/2. And so x dx is the top, that's du. And then the bottom is just the square root of u, which we could just rewrite it as u to the negative 1/2 power. When I find the antiderivative, I add 1 to the exponent and divide by that exponent. And so the 2's are going to cancel. We have square root of u, which is just square root of x squared plus 1. So that's v. Now we do uv minus integral v du. And so this is what we have. Okay, now we're going to do a u substitution. So let's ignore this first term. Let's focus on the integral. We'll let u equal x squared plus 1. And so du is 2x dx. Basically, this here is du, and this inside is just u. So it's just square root of u du, and then we use a power rule and get the antiderivative as just 2/3 u to the 3/2 power. And recall that u was x squared plus 1. So now we're just going to plug in x squared plus 1 for u. And so we have our antiderivative. So now we need to evaluate this at 1 and 0. So let's first plug in x equals 1. Well, this one I skipped a little here. If I plug in 1, I have 1 times the square root of 2. So that's just square root of 2 minus 2/3, and then 1 squared is 1 plus 1 is 2. So this is 2 raised to the 3/2 power. So I'm going to put this on the side here. I can break up 2 to the 3/2 power as 2 times 2 to the 1/2 power. And so 2 times 2 is 4. This is 4/3. 2 to the 1/2 power is the square root of 2. Now I'm going to get a common denominator here by multiplying top and bottom by 3. So we have 3 square root of 2 minus 4 square root of 2 over 3. And this is just negative root 2 over 3. So that's why I have negative root 2 over 3 when I plug in x equals 1. And then we're going to subtract it when we plug in x equals 0. Well, I have 0 squared here. That's going to cancel everything out. So we have negative 2/3, and then this is just 1. So that's why we have negative 2/3. Two negatives give me a positive. So the answer is negative root 2 over 3 plus 2 over 3, which if you want, you can rewrite it like this. Now let's solve this integral using u substitution. So let's ignore the limits for now. We'll say u is the square root of x squared plus 1. And so the derivative, you have to use the chain rule, which says to bring down the exponent, keep the inside the same, we'll subtract 1 in the exponent and multiply by the derivative of the inside. And notice the 2's are going to cancel, so you're just left with x over the square root of x squared plus 1. Okay. So one thing to note is here I broke it up. So x cubed is x times x squared. The reason I did that is because I know that x over the square root of x squared plus 1 is going to be du. So this that is circled is du. So now I need to find x squared in terms of u. Well, if I square both sides, over here I get u squared equals x squared plus 1 using this u substitution. So if I subtract 1 from both sides, I get u squared minus 1 is x squared. So now x squared will just be replaced with u squared minus 1. So I have u squared minus 1 times du inside the integral. And now this is pretty easy. U squared is just u cubed over 3. And then 1 is just u, the antiderivative. And remember, we said u was the square root of x squared plus 1. So plug that in here. Now we evaluate this at x equals 1. So if I plug in x equals 1, I have 1 squared plus 1 is 2. So it's a square root of 2 cubed, which I just wrote it as 2 to the 3/2 power. And that's over 3. Minus, if I plug in x equals 1, I have 1 squared plus 1 is 2. So it's a square root of 2. Okay, so this is when x equals 1. Now subtracted, when I plug in x equals 0, it's 1/3 minus 1. This thing is just negative 2/3. And so this is my final answer.